Good morning, afternoon, or evening. Delete as necessary. Today we are going to talk about the division of decimal numbers. And our objective is to provide experience with making magnitude estimates for quotients and using the partial quotients algorithm with decimals. So let's start off with, we have a rope measuring 87 and 6/10 meters long. It is cut into 12 equal pieces. Estimate the length of each piece. So how would we do this? We need to break up what we need to do first. And what we know versus what we don't know. So we know we have three things in this problem that we need to identify. So first of all, we know how many pieces we're talking about. Let me change my color. All right, there you go. All right. So, all right. So we know that we have 12 pieces total, right? And we know the total length, 87 and 6/10 or 87.6. What we don't know is the length per piece. So that's the big question mark and the question that we need to answer. And there's many different ways of doing this, but let's look at the way Everyday Math wants us to focus in on it. So Everyday Math wants us to use a magnitude estimate. Well, we did these for multiplication, so now we're going to use them for division. So a magnitude estimate, we will use magnitude estimates to insert the decimal point into the proper place in the quotient. The magnitude estimate will give us the place value of our answer, okay? All right. So let's go back. We had 12 pieces of rope, and we didn't know the length of the rope, but we did know we didn't know the length of each piece, but we did know the total length of the rope. Oh, Mr. Shanto. All right, let's try that again. All right. So how are we going to go about figuring this out? Well, dividing 12 into 87.6 mentally is not something that's super easy to do. But I do know some pretty concrete facts. I know that 5 times 12 equals 60, okay? Well, that's great. And I know 2 times 12, equals 24. And if I add those together, I would get 84, and that would be 7 times 12. Since I can add my 5 and my 2 together, that gives me 84. I'm almost at 87, okay? Another way to look at it is if I did sorry for the long pause there. I do have 9 times 12 memorized. I know 9 times 12 is 108, and so I'm way too big of my 87, right? So that's not going to help me. That's too high. Well, what if I take 112 away from 9 times 12? Well, that would give me 96, so I have 8 times 12. All right, so what I've been able to determine, the 87.6 is between 84 and 96, so that I know I'm going to be between, my answer is going to be between 7 and 8 pieces, okay? I'm sorry, 7 and 8 meters long, somewhere in there. Okay, but how do I know exactly what? I'm trying to erase. Let me pause. Okay, so let's go back and look. Let's start over again, and let's look at Everyday Math. So the first thing I want to do is I want to make an estimate. Okay, so my estimate is when I looked at my 12 I was using my 12s and I saw that 7 12s was too small and 8 12s was too large, I know that my answer is going to be in the ones place, right? Because 7 and 8 are both in the ones place, okay? So that I know is where my answer is going to be. So all I really need to do is use partial quotients and ignore the decimal point for now, okay? So I know that 12 times 5 is 60, well then 12 times 50 is 600, okay? And let me subtract, I get 276, okay? So next, I know that 12 times 2 is 24, so I know 12 times 20 is going to be 240, and I subtract, and I get 36. Well, I also know that 3 goes into 12, 12 goes into 36 3 times, and I subtract and I get 0. Add them up, and I get 73, okay? Now, is 73 a good answer for 87.6 or 87 and 6/10? Well, no, because 10 times 7 is 700, so we're totally way out of the game here. But I remember that my answer needs to be in the ones place. So my magnitude estimate is telling me that my answer needs to be 7.3 meters. So I made my magnitude estimate first, then I did my partial quotients with ignoring the decimal point, and then I added it in. You could even do this with long division, ignoring the decimal point, as long as you make your estimate first and realize what place value your answer needs to be in, but ignore the decimal point. Whether you use partial quotients or long division, it doesn't matter to me. Okay, so what's my big idea? My big idea is to make a magnitude estimate of the quotient. Is the answer in the tenths, hundreds, or thousands place? That's the first thing I want to do. Second, I ignore the decimal point and divide normally. Whether I'm using long division or partial quotients, it doesn't matter. Next, I use my magnitude estimate to insert the decimal point. And then, last but not least, I need to check that my answer is reasonable. And on the test, you have to do both. You have to do division, and then you have to do multiplication to check. There's points associated with both. Okay, so let's look at some answers. Let's look at this is our journal page, and I believe it is journal page 109, so we can do that along with me. So, first I need to make an estimate, okay? What is my estimate going to be? So I have 336.6, 336 and 6/10 divided by 3. What is the best way to make my estimate? Well, all right. Let me just round it to friendly numbers. Make it real easy on us. Oh, I need to zoom in. Erase, erase, erase. Zoom, zoom, zoom. Let's make it a little bit bigger. Okay. All right. So I get my estimate's going to be 30. Happy friendly number. Remember our friendly numbers? Divided, that looks like a plus, divided by 3 equals, 30 divided by 3 is 10, okay? So, I know that 30 divided by 3 is the same thing as 10. And so I know my place value actually needs to be in the tens place, right? So I have to circle my tens place for my place value. So now I've done my estimate. I've done my magnitude estimate. That's 1 point on the test. Doing the circle is the next point on the test. Now I actually need to solve, okay? So now I'm going to again ignore my decimal point. I don't need it right now. I can just do my partial quotients, okay? So, well, I'm 366, so I am going to do 3 times 100, which gives me 300. Okay, subtract, and I get 66. Okay, well, I know that 3 goes into 6 twice, so 3 goes into 66 22 times. subtract, I get 0. So I have 1, I add these together, and I get, let me pull it up a little bit, give myself some more room, 122, but remember that my answer needs to be in the tens place, correct? Tens place. So my answer needs to be 12.2. Okay? Let's move over to the next one. And I'll do long division for you long division fiends out there, because I know, oh, Mr. Santo, long division. I know, long division. All right, we'll do long division for this one just to make you happy. All right, 9.48. What am I going to round 9.48 to? Well, I've got a couple of choices. I could either do 8 divided by 4, which is 2, or I could just do 10 divided by 5, and I could round both numbers up, which equals 2. Now, does it change anything? Not really. 8 divided by 4 is 2, 10 divided by 5 is 2. My answer is going to be in the ones place, regardless of my estimate. So that's a good estimate, okay? At least I think it's going to be a good estimate. Let's do my long division. So again, I'm ignoring my decimal point, doing long division, okay? So 4 goes into 9, 2 times. 2 times 4 is 8. I subtract, I get 1. 4 goes in, I have to bring down my 4. Don't forget your next step. 4 goes into 14. 3 times. 4 times 3 is 12. Subtract. I get 2. Bring down my 8. 4 goes into 28. 7 times. 4 times 7 is 28. Subtract. I get 237. But remember, my answer needs to be in the ones place, right? Ones place right up here. So my answer is going to be 2.37. Okay? Okay, next one. $18.55 divided by 7. So what am I going to round to? Well, 18.55 divided by 7, not great. Well, what if I did 18 divided by 6? Ooh, and I get 3. So again, I'm going to be in my ones place. Okay? So again, it's a good estimate. Doesn't matter what your estimate is as long as it's a good estimate and you're using friendly numbers. Okay? And it doesn't matter which numbers I round to. I wouldn't really want to round 18.55 to 21 or to 14 because those are really kind of far away. Not that it might change anything because my place value would still be the same. All right, so let's do partial quotients. Okay? And again, I'm ignoring my decimal point. Okay? So, partial quotients. 7 times 2 is 14. 7 times 200, 2 times 20 is 140. 7 times 200 is 1400. And it's underneath, so I can subtract. Okay, so I get 5, 5, and 4. Now, what's next? I could do 7 times 40 gives me 280, and I subtract, and I get 5. Let's do some borrowing. 175. Let me pull it up a little bit. Okay. Next, that's a 5, by the way. I know 7 times 20 is 140. Brings me down to get 35, and I can do 7 times 5, and I get 35. And that would give me 0. I'm at the end of my slide, so I'm running out of space. Okay, 200 plus 40, 240 plus 20, 260 plus 5 is 265. Okay. Oh, let me zoom up. Oop, zoom, please. Thank you. 265, I said, right? Oh, I didn't do my I lost my estimate. What happened to estimate? Estimate. Come on, software. All right, 18 divided by 6 equals 3. 265. But it's in the ones place, correct? So $2.65. Most excellent. Let's look at the next one. Let's make an estimate. Crazy as it sounds, let's make an estimate. Let's do 7 divided by 7 equals 1 in the ones place. Long division. 6 goes into 7 one time. 1 times 7, 1 times 6 is 6. Subtract, I get 1. Bring down the 8. 6 goes into 18 3 times. 18 times, or 6 times 3 is 18. Bring down, or to get subtract, I get 0. Bring down my 4. Give myself some more room. 6 does not go into 4. Okay, so I need to make that a 0, and now I've moved it so I can't write. All right, let's do that. 0. Bring down my 2. 6 goes into 42 7 times. 6 times 7 is 42. 42 minus 42 is 0. I get, let me zoom up. 1, my pen back. 1307 is my answer. My decimal needs to be in the ones place. Bam. Okay, just like that. Okay, last but not least, we have 560 and 1/10 divided by 3. So let's make our estimate first. So let's make it a nice, friendly number once again. So we end up getting, actually let me zoom in a little bit. Zoom, zoom, zoom. Okay, we end up getting 600 divided by 3 equals 200. So our answer will definitely be in the hundreds place. Okay, let's do the work. So we have to do, again, we're ignoring our decimal point at this point. We do not need to pay attention to it. Partial quotients. So I know 3. Oops. Let's get rid of that. Let's try again. Okay. All right. 3 times 1,000 equals 3,000, and I subtract 2,601, and I know that 3 times 800 is 2,400, and I subtract and I get 201, and I know that 3 times 60 equals 180. I subtract and I get 21. I gotta move it up a little bit more. And I know 3 times 7 equals 21. I get 0. So I have 1,867. So my answer is going to be 1,867, and my decimal needs to be in the hundreds place. So my decimal goes between the 6 and the 7. So 1,806.7. Next example, which will be our long division example. 3 8400 divided by 6. So I need to do a estimate. And so what number am I going to look at that's going to be a nice round number that 6 goes into? Well, I can do 3.6 divided by 6. Well, I know 36 divided by 6 equals 6. So 3.6 divided by 6 has got to be 0.6. So for my estimate. So it's going to be in the tenths place. Okay, so let me write out my actual division problem. And we will do long division for you long division peoples. Okay, let me roll it up. So 6 goes into, doesn't go into 33, so it goes into 38. 6 times 6 is 36. Subtract, I get 220, bring down the 4. 6 goes into 24 4 times. 4 times 6 equals 24. Subtract, I get 0. Now, let's go back up. My answer is going to be, my answer is going to be 64, but it needs to be in the tenths place. So it's going to be 6.64. So as you can see, you can do all of these with the estimation, and then you use the estimation to look at your decimal point. Okay? So all you need to show me tomorrow is your math journal, page 109, and that'll be good. All right? See you in class.